In this video, we'll be exploring on how a microphone picks up sound in the real world. By now, you should be familiar with something like this. This is a Shure SM58, where you will be using in class to first capture sound and then send the output of the microphone to an analog mixer or digital mixer. In this video, we are going to focus on a few actual pickup patterns that you might encounter throughout your career. They are omnidirectional, cardioid, supercardioid, hypercardioid, and bidirectional. So what we want to achieve here today is we are going to do a science experiment to figure out how various pickup patterns actually affect the incoming signal that is coming out from the microphone. Right, welcome to the experiment. In this setup, what we have is a condenser microphone that's connected to an analog mixer. And with that, we are able to monitor the incoming signal that's captured from the microphone itself. So we are going to do an experiment where we have Celine over here holding a speaker, and what she's going to do is she's going to orientate herself in a polar plot, starting from 0 degree all the way to 360 degrees. So it's one circular round. Okay, so we're going to start this experiment. Right, so with 0 degree, what we get is actually an incoming signal of 0 dB. So that is actually over here. Okay, we'll move to the next one. Next one. Zero. Next one. Right after the experiment, this is the result that we get. What you can see on this polar plot is at 0 degree and 180 degree, basically the front and the back of the microphone, we are hovering at an input signal of roughly around 0 to -3 dB. So that is fairly sensitive. But if you notice this, at 90 degree and 270 degree, we are hovering at the signal level of around -25 dB. -25 dB. That is quite a big jump. What it means physically is the microphone is actually fairly sensitive at the front and at the back of the microphone. But as compared to the side, the microphone loses sensitivity. That means it's not as sensitive picking up the left and the right signal. So in this case, this is what we call bidirectional pickup pattern, where the microphone will focus the pickup at the front and at the back, but reject sound at the side. Next, we're going to explore a new polar pattern. Here goes. Play. Right, from the result, what we see is actually a inverted heart-shaped pickup pattern, where at 0 degree, the mic is very sensitive, 0 dB. But at 180 degree, the back of the microphone, we are getting a signal at around -25 dB. But it's fairly equal, symmetric on the side, where at 90 degree, we are getting somewhere at around minus 15. At 270, we're also getting around minus 15, minus 10 dB. So this is the iconic shape of a cardioid pickup pattern, where the microphone is meant to be picking up sound from the front, but rejecting sound at the back. So this is the iconic cardioid pickup pattern, where the microphone is meant to pick up sound from the front, 0 degree, which is in this orientation, but reject sound at the back, which is 180 degree at the back of the microphone. This is very useful because in stage application, where the user is using the microphone, the user will speak into the mic, and that's where you want the sound to be at here. But on stage, you have stage monitors. You want to reject the sound from stage, so this area. So in this case, with this rejection over here, what you actually achieve is higher gain, or what we call higher potential gain, because with rejection here, you can actually bring up gain way higher or much more to achieve good signal at the front over here. Next, we're going to explore a different polar pattern as what we see from the previous two. So again. From the experiment, this is the result that we get. You can see that from 0 degree, 90 degree, 180 degree, 270 degree, the pickup pattern is more or less consistent with some small discrepancy at around this region. But overall, it does not vary as much as what we've seen from the previous two polar patterns. For example, from the bidirectional pickup pattern here, the 0 degree and 180 degree, these are the two that is more sensitive as compared to the left and right. But comparing this to this is way more consistent than a bidirectional. And in this case, this is a omnidirectional microphone. I hope that from this experiment, everyone can have a simple understanding on how various pickup pattern affects the microphone, how each pickup pattern characterize the microphone in the way it picks up sound from various angles. So hope to see you soon in class.